11.4, particle motion from an equation. This is level 2. Number 1, we've got this particle moving along an x-axis. Didn't know so many particles moved along an axis, did you? So that time is greater than or equal to 0, and we're given its position function. Terminal intervals when the particle is moving to the right. And so we would want to figure out where is the velocity positive. So we would want to take the derivative. That would be negative 20 t cubed plus 60 t. We want to find the critical values or figure out when is it coming to a resting point. So where is the velocity 0 so that we can make a sign chart and figure out where velocity is positive or negative. Out of this function, I would want to factor out a negative 20t. That would leave me with a t squared minus 3. So that gets me a time of 0 here. This can be solved, set it equal to 0. You're going to add 3 and then square root it, which gets positive and negative square roots of 3. We have to throw out the negative answer because we can't have negatives. So my sign chart is simply going to have a 0 and a square root of 3, which as a decimal, it's going to be less than 2 because it's not square root of 4, but it's going to be about 1.7, just so you know. So I would want to pick a value bigger than that, and that would be about 2 I would plug in for my velocity. 2 squared is 4 minus 3 is positive, but negative 20 times 4 is a negative. Negative times a positive would make this a negative velocity. And then at square root of 3, I would look here. This is an odd function, so it should change signs. If you weren't sure, you could pick like a 0.5, 0.5 squared. So 0.5 times itself is 0.25 minus 3. That's going to be a negative, and then that's definitely going to be a negative. So negative times a negative makes it positive, because there wasn't a multiplicity of 2 on the outside of the factor. So where is the particle moving to the right? Where our velocity is positive. So we would say between 0 and square root of 3. And I would not round that radical, I would leave it. Number 2, a particle moves along the x-axis, so the time greater than or equal to 0. Its position is given by that function. Terminal intervals when the acceleration of the particle is positive. So now we want to take the second derivative. First derivative is our velocity. That'd be 6t squared minus 12t plus 6. Acceleration is going to be 12t minus 12. We want to find the critical value, so we'll replace the acceleration with 0. Easy enough to factor. We'll take out a 12. That'll be a t minus 1. 12 does nothing for us. We get a time of 1. So from 0 to 1. And again, because I'm never going into the negative times, so I would try plugging in 2 to my acceleration. 2 minus 1 is 1 times a positive 12 would be positive, and then since this is an odd multiplicity, it should cross through. So where's the acceleration positive? Anywhere after 1. So let's say 1 to infinity, because it never says that it's going to stop the time. And last one, a particle moves along the x-axis so that at time t is greater than or equal to 0. Here's its position. Determine all intervals when the speed of the particle is decreasing. So we need velocity and acceleration to have different signs so that the speed is slowing down. So I'm going to have to find velocity and acceleration. That would be a 12t cubed minus 36t. And then acceleration is going to be 36t squared minus 36. Factor those, set them equal to 0. So I can make 2 sign charts. I would take out a 12t. That'd leave me with a t squared minus 3, which would give me a time of 0. And we already know this gets positive and negative square root of 3, but I'm only going to get a positive answer to fit my domain. This one I'm going to take out a 36, and then have a t squared minus 1. Can't factor that, but that factors into t plus 1, t minus 1, or add 1 in square root, you get plus and minus square root of 1, which I can't use a negative one, it's just 1. Okay, so here is my velocity sign chart. We got our 0 and we got our square root of 3. And then acceleration, we're going to have our 0 and our 1. Now, what did we say the square root of 3 was? Almost 2. So I'm going to put 1 in here so I remember that it's actually coming before square root of 3 would. Okay, so if I want to know my velocity at, let's do 2. Plug it in, 2 squared is 4, minus 3 is positive, positive. And again, this is going to cross, so that will be negative on the other side. Acceleration, I'm also going to try at 2. So that would be 2 squared is 4 minus 3, that's positive, positive. This is really, we said t plus 1, t minus 1. So our multiplicities are both 1. So when it's this, it's going to cross. And so I want to know, where do they have different signs? So let's split this up into saying 1 is in here and then square root of 3 is here. From 0 to 1, I have a negative velocity and a negative acceleration. That's the same sign, so it's not that interval. Then I would go from 1 to square root of 3, I'm still negative, but 1 to square root of 3, my acceleration is positive. Those are different signs. So here and here, and that's just my trick of helping you go from interval to interval. So 1 to square root of 3, and then square root of 3 to say 2 is positive velocity, and that would be positive acceleration. And so that has the same sign. So that's our only interval where we're decreasing in speed.